Good afternoon, my name is Paul Sanderson. In this short demonstration video I intend to show you some of the basic features of SQLite Recovery Forensic. When SQLite Recovery Forensic is first run, the wizard appears and you'll see the screen as shown in front of you. The first thing we need to do is choose a folder that our output files will be placed within. In this case we've got a pre-created folder called Demo1, I'll use that, and then we choose the next button in the wizard. Next we decide which databases we want SQLite Recovery to search for. What I'm going to do now is add a new database template which will be saved for later use so we don't have to do it a second time. I'm going to import the database schema from an existing SQLite database. So we click on the pop-up menu and I'm going to choose main 1DB down here, which I know is a Skype database, and when we choose OK we need to tell it SQLite, or give SQLite Recovery a application name. So in this case we're calling it Skype. Choose OK, and after a couple of seconds we get a new application in this left hand box. Click on that and we can see in the databases box we have our main 1.db file, and then within the tables we have the tables from the Skype database, and for each of these tables we can see the different columns and the column types, and we can scroll through them. So we'll choose Skype to extract. For the purpose of this demonstration we're just going to have one application selected, although we could select all. But what we're also going to have down the bottom here is search for database definitions. Basically what this does is as a first phase of the search, SQLite Recovery will look for database schemas and then use those to effectively populate a grid, and we'll see the results of that later. We now hit the next button to find the last item, which is we choose what we'd like to carve from. We can choose encase or EO1 files. We can choose physical or logical devices, or we can choose individual SQLite databases or unallocated space files, etc., raw files. In this case I'm just going to carve a 3 GB demonstration volume, which is my drive I, and then we hit finish, and that's a basic process. And we can see SQLite Recovery is chuntering away now, and I'll let that carry on and get back to you when it's complete. So here we have the results of the carve process. The SQLite Recovery display runs as follows. Down the left hand side we have a tab for an SQLite Recovery tab, which is internal data, which we'll come to shortly. We have the Skype application that we created and the fields within it, and we can see across the top we have the main DB. If there was more than one database file within the application, for instance Firefox has multiple files, then we'd have a number of tabs across here. For each database tab we'd have a number of tabs, one for each table within the database. And we can see within each of these we've got in the DB meta table there are 208 items, in the contact groups there are 91, etc. And finally we have the carved databases tab. This is all the other databases that SQLite Recovery has managed to find, so we haven't specified them as a particular type as in the Skype one, but it's gone off and found them anyway because we click that checkbox at the bottom, and we can see there's quite a few of them, and we can see DB0 at the top. We don't know what application it's from at this stage, we just have a schema for it, but we can see there are a number of tables within this particular database. And in this case I happen to know that this is a Reconnoiter case file database, and we can deal with that and add it to the templates later. Now we want to look at how we can filter the displayed data. Looking in the DB meta table, I'm going to stick to this because there's case sensitive information or information that can identify individuals in the other tables. We can see that in the DB meta table there are a number of values and another empties, some of which are valid and some are not. So what can we do to filter this data? Well, the first thing is we can right click and from the pop-up menu choose delete duplicate rows by MD5 and we can see in this case there are 1447 duplicate files, and we can delete those and get rid of them. So we can do that, and we can see that there's now 208 files, a lot less than there were before. Still quite a lot. The next thing might be to look at a valid SQLite database and see what information is displayed within that database. And if I just drag this across here so you can see it, this is an example of a main DB, and we can see that we have just one row in the key field, current schema name, I assume that is cur schema name, and a value base 1.0. From looking at Skype databases, this is cur schema name is the only value I've ever seen from experience, so we can use that as a filter. So how do we do that? We can filter just the displayed data for the moment by clicking on the customize icon and button on the bottom right hand side. We can then add a filter and we choose the field we want to filter on. So the field in this case is key, and we only want cur schema. Well, we can add cur and then a %, and then choose apply, and that gets rid of all of those other values which aren't valid. And then we choose OK. That information is all that's left and all that's displayed. We can get rid of that filter by clicking on the little tick box at the moment to show whether it's active or not, and we can see that all that data's back. What else can we do? Well, it would be better if this information didn't end up in this particular table to start with. Although it might be interesting, it doesn't belong. Most of it belongs in a different table. So what we can do is a parse time filter. So if we now fire up the wizard by going to the file dialog and wizard, hit the next button again, which takes us back to this particular dialog. Click on Skype. Only got one database, so main DB, and click on DB meta. We can see that we've got two columns, key and value. Our key field is the one we filtered on, so if we right click on that and we choose new constraint, it's a constraint on our key column, and if we do starts with, and if we put CUR in there, choose OK, and then choose cancel, that information is now entered within the constraints database. So when we next run this this carve process, then that constraint will be applied, and only records which have a key which starts with CUR will be added to this table, and we'll do that to show it sometime later. The final couple of things I'd like to show you within this introductory video are one of the additional viewing facilities available within SQLite Recovery. The first, if we click on the calls tab, we can see that in this particular database we have a number of dates and times, and we can see that some of them don't appear valid down the bottom. We'll ignore those for the purpose of this demonstration. But we look at the begin time column. If we right click on that column and choose view column as, we can see we've got a column conversion dialog, and we can choose how we'd like to see this data. In this case, I happen to know that the Skype date and time is recorded at a Unix 10-digit timestamp, and for anybody who's familiar with the timestamp, they can see that actually looks like one anyway. If we choose OK, we can now see, if we resize this dialog, that these calls have been displayed in the correct format. What else can we do? We can export a certain amount of data to XLS, so we can export these files to just a selected rows to an XLS spreadsheet. No point going through the dialogue on that, it's quite straightforward. The final thing to do is show you the output file or the output folder structure. If we drag our Windows Explorer dialog across, we can see we have our SQLite Recovery case file within our Demo1 folder. This is, if you like, the unsurprisingly an SQLite database which contains all the information which is used to form the display. Within that we've got two folders, our Skype database and our carve databases. Within Skype, as we can see, is our main DB and a journal file which is open because the application is still running. And within our carve database we've got a number of files, DB0, etc., which are all the individual SQLite databases that SQLite Recovery found for us and can then be hopefully investigated with another forensic software package if we don't need to, or if SQLite Recovery isn't enough on its own. So for instance, you could load the database into a Skypelizer or even something like NetAnalysis.